Okay, so we're going to do the heck reaction. This is another coupling reaction. And I'm going to sit next to an open window with the cars driving by, and hopefully that will not be too distracting for you. All right, so the heck reaction in section 28.8 is another coupling reaction. So we're going to make a new carbon-carbon bond. All right, we've done this several times now. And here's the next example. The next example is I've got a carbon here and a hydrogen here, and this is going to get replaced with an R group, okay? Now the R group can be aryl, vinyl, or benzyl, and that restricts it a good bit, okay? Aryl, vinyl, or benzyl, and that's it, right? I don't think I have much more to say about this. You need to think, there's an example down here, but let's go, before we do this, let's practice like we did last time. Let's practice, go with blue, and like we did last time, okay? So we had a double bond. Let's think of the simplest one. Oops. Okay, simplest. This is the one that if it's on the quiz, you'd think, oh my lucky stars, okay? Wow, so easy. And you need to write this out. If you don't do this, you're not grappling with the material. So please pause this and write the simplest reaction. Okay, let me suppose you paused it, and I'm going to think of the simplest one. All right, so here it goes. If the simplest one, it was an R and a halide. I'm actually writing out what the book says first, okay? Plus right. Let's go to the book. PDL2, and I think this is in basic conditions, but let's go over here. Where is this? Where are we here? Oops, wrong pages. Okay, sorry. Should have had this ready. There's the Suzuki, which we did a minute ago. We're skipping the Nagishi. Skipping that one. We're going to go straight to the heck. We're going to heck in a handbasket. There we go. Right? All right. So it looks like it's in basic conditions. Can you see that? This is on page 33. So let's go back over here. We're going to say page 33 as a hook to help us remember it. And this is in basic conditions. Let's go back over here. Was that base given to us? No, nothing about that base was given to us. Base. Let's look through here. Any of these? There's a base. Okay. So it looks like this could be, here's a specific example. It looks like it could be given triethylamine. All right, so we'll do that in a minute. For now, it's base. All right, and when that happens, what we're going to get now, am I back in blue? Blue. Here's my double bond, and this gets replaced with R. Bam. Okay. Now that's the example, but that's not going to be in the exam on the quiz. That's just too general. So let's do the simplest specific example that could be on the quiz. Okay. CH3X plus that. I'm going to do this in a different color just to get my eyes used to it. PDL2. This is a palladium 2 catalyst. Let's go back to blue. All right, that's the simplest one I can think of. All right. Let's add the next. Let's do the next simplest. Please pause the video. Oh, wait a second. That was an alkyl. No. This is why it's so good to do the simplest. No, this doesn't work. because the simplest was not an alkyl, right? It was, this is why it's good to do this. We learn like this. Yeah, it was an aryl, or a vinyl, or a benzyl, right? Let's go back and look. For the heck, R has got to be, look at that. Can you see it? It's too small there to see in your page. Let's see if I can get rid of this. Can I get rid of that little window right there? All right, let's forget it. All right, so look at this. Uh-oh, lost it. There we go. Look at that. It has to be an aryl, a vinyl, or benzyl. So no, this is not the easiest one. The easiest one, oops. Okay, let's go back here. The easiest one is going to be, well, what's the simplest aryl, vinyl, or benzyl? I don't know. I mean, probably, you know, your guess may have been that. Right? Am I red yet? Nope, here's red. PDL2 and base. Okay, that's a good one. It's not the simplest. I think the simplest would be vinyl, so why did I choose that? Well, I thought maybe, I don't know, it sort of depends on what your eyes are used to looking at, right? Let's do a vinyl now. Vinyl would be that plus that, right? And I'm a little bit nervous about the number of carbons here. PDL2 in base. Page 33. Let's go back. Let's number it in red. 1, 2. That's going to get coupled with, right? There's the hydrogen that got lost. 3, 4. Watch this. 1, 2, 3, 4. Okay. And so I guess the question is, will it be this or... I'm not going to answer this question for you. I want you to tell me. Is it going to be that or that? Is it going to come in this form? Let's call this form 1 or form 2. And I'm not going to answer that for you. You bring that to class. All right. So that's maybe the simplest. Okay. Now let's add a layer of complexity on there. Let's go back to blue. And let's say that... let's add a layer of complexity on here. And let's say that plus that. Let's do that one. You can see I've got to go back in the book. PDL2. You know what? I'm going to add another base this time. I'm going to say triethylamine. And that was on, I don't have the page number here. Let's go back to triethylamine. Showed up on page triethylamine. And look at, there's another way that's, look at how that, the PD catalyst is, there's my L2 is right there. It's ugly, isn't it? So we'll play around this as we practice. This is on page, I can't tell, page 34. All right, so this is on page 34, okay? Now what's gonna happen, I'm gonna come over here and make a note to myself, that's where my new guy goes, and here's the new guy. All right, so let's go back to blue, and I'm gonna say this is, let's go back to red for numbering. 1, 2, 3, 4, 5, and on carbon 4 there's another methyl group which I'm going to call X. All right, so it's 1, 2, 3. Looks like there's a double bond there. 4 and 5, and there's my X right there, and that's it. Son of a gun. 1, 2, 3, 4, 5. That's it. There's my new bond right there between 2 and 3. And there's the, see, that's the new bond between 2 and 3. Wow, okay. All right, now one more thing, which I don't think I did in the last video. I'm going to ask this same question, but a different way. Now I'm going to say, let's go here, go here. Now I'm going to say, use the heck to make oh, that wasn't even a question in my last one, right? That wasn't a question, it was the simplest reaction. All right, use the heck to make this fill in. What reagents would react in heck to produce 1, 3 butadiene? Okay, this is an easy question. Well, I shouldn't say easy. I don't even, it's not even easy for me. But you know, but it's about as simple as we can get with heck. It's about as simple as we can get. All right. Wow. So what am I going to do to solve this? Well, first of all, I'm going to find the new bond that was made. The heck makes a new carbon-carbon bond, and that has to be it right there because it's a single bond that's made, right? So I'm going to pull this guy off. Pull this guy off. I'm going to call this A and this B. A plus B. And A, the new bond, remember now, comes off of an of a halide, and this comes off of hydrogen. Wow, that's it, and there's our answer. But you see, systematically, I've got to make notes to myself with my pencil. I could never do this in my head, and I think most students cannot either. So please, please get used to using your pencil. All right, let's go back to the PowerPoint. So I know this is gonna be another long video, but I feel like the extra help is gonna be useful to a lot of people. So bear with me. Where am I here? Shift F5. Okay. So the heck reaction we just started. Now we're gonna take an R and replace a vinylic hydrogen with that R. And there you go. Right. So I've got this, which I'm gonna draw as triangles so that your eyes can see it better. Okay. Can you see that? And I'm replacing it with an R group. Okay. So the heck reaction is one of the most widely used carbon-carbon bond forming reactions. Great. That means it's important, I guess. Okay. Thank you. Now here's an example. All right. Well, here's that weird OTF again. Triflate is what we're going to call it. A vinyl triflate. That means it's a triflate that's in the vinylic position. And so we're going to add that. We're doing the heck because we're doing PDL2 with a base. We're going to take a hydrogen and replace it. We're going to replace that hydrogen box with triangle. Okay, so I'm going to come over here, and there was my box. This got turned around, by the way. I should have said that. I should have said we were going to do this one. Box. You see, those are the same, so it doesn't really matter. Okay, and there's the new, there's the old one. There it is. Okay. So, and the same question that I asked you but didn't answer there is this going to be oriented in that fashion, or is it going to be rotated 180 degrees? Okay, I don't think I want to say much more about this. We're going to look now. We do want to spend a minute talking about that double bond and about that group right there, which is either an aryl of vinyl, which is, this is vinyl, or benzyl. And vinyl is if you got a group coming off of a double bond. Okay, don't memorize that group. That's not, vinyl is a general name, not a specific name. All right, so the Heck reaction is compatible with many functional groups, including alcohols, ethers. That's good news. Alcohols, ethers, aldehydes, ketones, and esters. So you ought to make up a practice problem for each one of these. Make up one for alcohols. Make up one for ethers. It's going to be ugly. Make up one for aldehydes and one for ketones. You're going to find some ugly, hairy was what I mean. Things that have got lots of detail on them, right? And they'll be scary looking. So make one up. The Heck reaction is compatible with many of these. Palladium catalyst or a PD or PD2 catalyst can be used. We don't need that. And the base is used to regenerate the catalyst, as we will see later in the mechanism, which we're not going to do. Okay. So importantly, though, we will see this. Okay. You got to know. Listen, if you're saying, well, how would I know which things to cross off and which things to not cross off? I would say this. If you're predicting this yourself, this is foundational. The easiest possible question would include something like this, but not necessarily deep. These are not the easiest things. That's really deep. And so we start out with the structures, right? You start out with what you're going to see. And you have to see something. You have to see some structure in this reaction, or else we wouldn't be doing it, right? All right, so now ethene is the most reactive alkene in the Heck reaction. Ethene is the most reactive. Most reactive alkene. So this is not ethene, right? This is 1, 2, 3, 4. This is butene. And I should start on this one. 1, 2. 2-methylbutene. 2-methylbutene, right? Ethene's the most reactive in the Heck reaction. Monosubstituted, and that's good news, right? That means that as we get more as we put something on there, it's not going to keep going. This is interesting. What does that mean? Ethene is the most reactive alkene. That would be a good subtle question. Hard, I think. After we put it in our group on ethene, it's going to stop because ethene's the most. Oh wait. Yeah. Because ethene's the most reactive. Exactly. So monosubstituted alkenes are slightly less reactive, but their reactivity is increased with the presence of an electron withdrawing group. Okay, so what's an electron withdrawing group? Well, we've done this before. We did this in our here's an electron withdrawing group. We did this on our electrophilic aromatic substitution. Electron withdrawing group, right? Why? Because you've got a carbon there. It's partial positive and it cannot feed electrons into the system. Here's another electron withdrawing group, another one, right? We memorized those before. So if you put one of those on an alkene, you're going to have a good reaction. So you should practice with one of those. And I'm not going to do that in this video. Bring one to class. Bring a practice question like that to class. All right, and reactions on a monosubstituted alkene occur regioselectively and stereoselectively at the least hindered position. All right, so here's a monosubstituted alkene. You've got one thing on there. It's an acetyl group. And so the least hindered position is going to be over here, right? And that's exactly what happened. Wow. It's opposite, right? You see that? It's going to be E to the substituent. So this one's not. I can't use. Well, this example is going to have to be good enough for the least hindered. For the least hindered position, there it is, right there. If X is vinylic, and there's my X, and it's vinylic because it's right on a double bond, then RX will retain its stereochemistry. So you see, I've got an alkyl group and a halide. When they're across from each other, they're E. So this new bond that's formed is going to stay over on this side. It's going to be, this is E to that. All right, and likewise, if this is Z, and this is going to be Z, the new thing is going to come on as a Z. All right.